Easy Learning with Krishna Joshi. I am Krishna Joshi and today we are going to learn motion chapter, NCERT physics chapter. So let's start with it directly. So first topic is uniform and non-uniform motion. So what is it? When an object covers equal distance in equal intervals of time, so the object is in uniform motion. So when the object covers equal distance in equal interval of time, see here you can see this is meters, so this is the distance time graph, and this is 10 meters in 1 second. So 10 meter per second you can say the speed. And the other one is when an object covers unequal distance in equal interval of time or vice versa, so the object is non-uniform motion. So see here it covers 10 meters in 1 second, so equal distance in equal time. Okay, the second part is it's not covering 20 meters in 2 seconds, it's covering more than 20 meters in 2 seconds. See, 20 meters is here, no sorry, yeah, 20 meters is somewhere here, and the distance covered is 20 meters, and the time taken is more than 2 minutes and less than 3 seconds. So 2 seconds, and yeah, so this is non-uniform motion graph. Next is scalar and vector quantity. So the scalar quantity, no, here is a vector quantity. The quantity which have magnitude as well as direction is known as vector quantity. For example, force, velocity. So if we are talking about velocity, we specify the speed as well as the direction in it, or the displacement in it. Then the second one is quantity which have magnitude in is known as scalar quantity, which only have magnitude, that is speed, time, mass, etc., which only have one unit. And velocity have, see, it have direction also. So next topic is difference between distance and displacement. So the distance and displacement difference is here, and this is the similarity. So distance is always positive, displacement, it can be positive or negative. Negative displacement is also there. The similarities is unit of both of them is meter. So we get covered we can say we covered 1 meter, and it's a straight distance also. It can be a curve also, that, and displacement is always straight, is one dimensional only. And then the second point is it will not be zero when the body comes back to its initial position. So wait, I'll show you with the pen. So if the see, if the body goes like this and then it comes back to the initial position, this initial position, then the distance will be total of this both, total. And the displacement is, it will be zero when the body comes back to the initial position. So if it goes like this for 1 meter and then again comes back here at this point, the displacement will be zero, whereas the distance won't. Then the similarities is distance and displacement, there's a mistake. Distance and displacement are equal when the body is moving in a straight line. So as I told, if the body is moving in straight line, see, then it's one dimensional, so the distance will be this much and the displacement will also be this much, so it will be equal because it's moving in one dimensional track. Then the last point is, as I told before, distance is vector quantity and displacement is scalar quantity. Then difference between speed and velocity. Mm, Speed and velocity difference. See, the speed is distance traveled per unit time. So there was a graph we saw like this. This is time this is distance and this is time. So yeah, like that. And similar, velocity is displacement per unit time. It's only displacement. So as I told before, it goes and comes back. Then the velocity will become zero because the displacement becomes zero. Then the scalar quantity is, the speed is scalar quantity and velocity is vector quantity. And the similarity is SI unit is meter per second for both of them, per meter second. Yeah. And the other similarity is both expresses magnitude, only magnitudes. Both expresses magnitude, but velocity expresses not only magnitude, even direction, north and all, like that, north, south. No. So you can say I traveled 1 meter towards the north direction. Or if you're a friend and you are living somewhere and you are asking where is your house, if he says only that I traveled, no, you should travel only, you should travel 5 meters. Then you'll be like, which direction? Here, here, or here, which direction? So if you tell 1 meter towards or 5 meter towards the south, then he can easily get there. Okay, it's towards this side. Okay, yeah, I got his house. And speed average depends on the total distance covered and time. And here the average depends on displacement. So yeah, and average speed and average velocity formula. See, u is initial velocity, v is final velocity, and t is time taken. Average velocity is v minus u by t. V is final velocity, u is initial velocity. So final velocity minus initial velocity by time. And the average speed is distance, total distance covered and time taken. The distance covered and time taken divided by time taken. When the displacement is given, the average velocity is displacement by time. Yeah. Then to convert kilometer per hour to meter per second, we need to multiply the given value in kilometer, the given value which is in kilometer per hour, to 5 by 18. That the value which you get will be meter per second. Then the second point is to convert meter per second to kilometer per hour, we need to multiply the value by 18 by 5. That's just the reciprocal. You need to remember this. So whenever they give us a question like in kilometer per hour, they'll give us the speed or velocity. Then yeah, then in the answer they will ask you like write the answer in meter per second. Then you need to use this. That you can find the answer in kilometer per hour, but at last you can multiply it by 5 by 18 to get the answer in meter per second. And same here, if they give us in meter per second and they ask you to answer in kilometer per hour, then you will use this, like at last you will multiply 18 by 5. Then there is an example from textbook only, example 8.3. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute. By swimming from one end to the other and back along the same straight path, find the average speed and average velocity. So the answer for it is total distance covered by Usha. First you need to write what is the values given. The total distance covered by Usha in 1 minute is 180 meter. It's given. Then so first they ask us to find average speed here. So we'll find average speed. What is the formula of average speed? Total distance by total time taken. We saw it. So total distance is 180 meter, which is given. Total time is 1 minute. So 1 minute by, so he converted it to meter per second, because here it's meter and here it's minutes, so it won't be proper. So he just did like 180 meters by 1 minute into 1 minute by 60 seconds, so you will get the proper answer, that is 3 meter per second. Then the average velocity, here they have given displacement. No, it's just like she goes there, this is 90 meter, you can say 90 meter, and then she goes and then she comes back. So she again came to the initial point, so the displacement became 0. Yes. So average velocity is displacement by time, total time taken. So displacement is of course 0 meters because she came back, and the total time taken is 60 seconds. So 0 divided by any number is 0. So the answer is 0 meter per second. The average speed of Usha is 3 meter per second, and her average velocity is 0 meter per second. Then another example. Example for calculation of distance traveled and displacement. See, you can see. So I took it as yeah. David walks 3 kilometers towards north, then turns and walks 3 kilometers towards east. See, 3 kilometers towards north and 4 kilometers towards east. There is a mistake here. It's 4. Okay, sorry. Then calculate the distance traveled and displacement. So the distance traveled is total distance, that is 3 plus 4. Here it's see 7 kilometers. Displacement is root of AB square plus BC square equals AC. So it's a triangle, right? So this distance will be the displacement. Understand? But I will take the pen and see. This distance is the displacement. Since the displacement is the smallest distance which we can say, and it is one dimensional, it can never be like this and then like this. See, so we are using Pythagoras theorem, nothing much. So this is uh, AB square plus BC square is equal to AC. So you can mark it as A, this point you can mark it as B, this point you can mark it as C. So 3 square, this is 3 meter and square AB square, then BC square, that is 4 was a 16 here you see, and that's this. So 9 plus 16 is equal to AC square. What's 9 plus 16? 25. So 20 root of 25 is AC square. So if we take 25 5, then it will become AC. So AC equals 5 kilometer per hour. See, sorry, 5 kilometer. Sorry. Then thus the distance is 7 kilometer and the displacement is 5 kilometers. See, the total distance is 7 kilometer and the displacement is 5 kilometer. Acceleration. Now the topic acceleration. So if body is moving in a constant speed in same direction, remember direction, then there is no acceleration. If the body is moving straight with the same speed, like here also it was, here he reached in 1 second, you can say 1 second, then again here again 1 second. So the speed is constant, the distance is also constant. See, so the acceleration is 0. If body changes the speed or direction during the motion, then there is change in acceleration. So first he reached this is equal distance. Okay, I'm marking it as equal distance. So he reached in 1 second here. Then he took 2 seconds to reach here. This is equal distance. Okay, but he took 2 seconds here. Again he took 1 second. So speed is increasing, decreasing, increasing, like that. So it's this is the rough idea of acceleration. A denotes the acceleration. A. A is for acceleration. Here I wrote the formula for acceleration is v minus u by t. V is final velocity, u is initial velocity divided by time, SI unit of acceleration, most important thing, SI unit of acceleration is meter per second square, not meter per second, it's square. Yes, the example for this is starting from a stationary position. Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in next 5 seconds. Calculate the acceleration of the bicycle in both the cases. So see, in first case, the initial velocity is 0, the final velocity is 6 meter per second. See, first he starts his bicycle from stationary. He is standing here, then he starts and attains a velocity of 6 meter per second in time taken 30 seconds. Okay, 30 seconds. So the final velocity is 6 meter per second because he starts from stationary and he reaches to 6 meter per second. The final velocity is 6 meter per second, time is 30 seconds. From equation, this is the textbook equation, you can neglect it. So we have acceleration equals v minus u by t, the formula for acceleration. So substituting the given values of u and v, we get acceleration equals 6 meters, which is given final velocity, and the initial velocity is 0 since he starts from stationary, and the total time is 30. So when you divide 6 by 30, you will get 0.2 meter per second square unit of acceleration. Then in second case, the second case is that he again applies brakes and comes down to 4 meter per second. Then he applies brake from here, you can say, and he attains a velocity of 4 meter per second, which is deceleration or retardation also. So he applies brake and reaches 4 meter per second. In time taken, time is given 5 seconds. 5 seconds, yes. So this will be negative acceleration. Time taken 5 seconds, yes. Initial velocity 6 meter per second since he attained the velocity of 6 meter per second, and then he is applying brakes. Final velocity is 4 meter per second since he applied brakes and attained a velocity of 4 meter per second. Time taken is 5 seconds. So acceleration here is 4. The formula is the same, v minus u by t, initial velocity minus final velocity minus initial velocity by time. So final velocity is 4 meter per second, initial is 6 meter per second, divided by time is 5. So the answer after dividing you will get is minus 0.4 meter per second square. So thus we can say that the acceleration of the bicycle in the first case is 0.2 meter per second square, and in the second case is minus 0.4 meter per second. Minus because see here is minus and this is a big unit. This is basic of math, you see. Equations of motion. So the equations of motions are, which we will be using it further. So equations of motion. First equation, v minus v plus v is equal to u plus at. U is initial velocity, v is final velocity, a is acceleration, and t is time. Here no distance is not there. T is time. Okay. Then distance. When you want to find distance, s is for distance. S is distance or displacement. So when you want to find distance, when the initial velocity is given, you write it as ut plus half at square, 1 by 2 at square also. Then the third equation of motion is v square minus u square is equal to 2as. The fourth equation is v square equals to u square plus 2as. Example including the equations is the brakes applied by a car produces an acceleration of 6 meter per second in the opposite direction of the motion. If the car takes 2 seconds to stop after the brakes are applied of brakes, calculate the distance it travels during the time. So the car is moving and then suddenly applies the brake here, so how much distance did it travel and stop? That's what they are asking. So here is final velocity is 0 meter per second because it applied a brake, so it will stop. Then acceleration is negative 6 meter per second square because he applied a brakes and this acceleration is given of brake. Then time is 2 seconds. See, time is also given. So s is equal to ut plus half at square. So we need to find the value of u because we don't have initial velocity is not given. So u is equal to v minus at from the equations of motion. So you can see here is there is something. Yeah, see. Yeah, we need to find u, right? So the initial final velocity is 0 minus 6 minus 6 is the acceleration and time taken is 2 seconds. So the answer is 12 meter per second since negative multiplied by negative is positive. Now we have the value of u. This is u, okay. So the value of u, so x is equal to 12 into 2 plus half into minus 6 into 2 square. We are just substituting the values which we have in this equation. I'll mark it here. So distance covered after applying the brake is 12 meters per second. Hence the distance is 12 meters. Yes, the same thing. Uniform circular motion. Last topic. Tangent. Some key points are there. Tangent is the direction of the velocity of any point in the uniform motion. So this is a circle and you're standing here and rotating a rock tied with a thread. Then if the rock is moving towards this direction, this like this, then if it comes here, the acceleration is like this, velocity is like this, then here also, so it's like this. See, in uniform circular motion the speed of the body remains constant but direction of the motion is changing continuously. See, the speed remains constant, direction is changing continuously. First is here, then it's here, then it's here, then it's here, like that. Yeah. Therefore, we can say that uniform circular motion velocity is changing continuously. It's changing continuously, hence the acceleration, hence it is an accelerated motion. It is accelerating continuously because acceleration and this velocity affects acceleration. So, v in circular motion, so final velocity or the speed, yeah, speed here is denoted by v is equal to 2 pi r by t. 2 pi r is the circumference and divided by t is the time taken. So distance, this can be distance since circumference and the time is total time taken. Example, motion of natural or artificial satellite is a example of uniform circular motion. Then second is motion of electrons around the atom's nucleus. That is also a uniform circular motion. Numerical example. An artificial satellite is moving in a circular orbit of radius 42,250 kilometers. The radius is 4250 kilometers. So this is just the radius. It's not perfect. Calculate its speed if it takes 24 hours. So the time given is 24 hours to revolve around the earth. It takes 24 hours. So the radius is given, it's, in kilometers. So this is in meters. Okay, in meters it's uh, 4225000. So the speed is 2 pi r by t. So 2 into 22 into 42250, we took it in kilometers, divided by 7 into 24. So the approximate answer is 11056.5 kilometer per hour. The answer is in kilometer per hour. Okay. Okay. Hope you understood. This is what I taught today. I taught motion chapter of NCERT textbook. Hope you all have understood, and if you have any doubts or any queries, or you need any improvement in my teaching, then kindly comment below, and I insist you to subscribe my channel. Thank you.